using cylindrical shells. If we are given the area and the curve y is equal to fx here, if it is rotated about the y-axis, okay? At each point between the interval from A to B, we rotate it. It will create a cylinder here, right? Like this guy.
I don't have an answer for that. Something.
Sorry, Siri. Okay, then at each lines here, you can compute the volume of this when you cut the cylinders here. The length of that will be 2 pi x. The height in this case is the distance from the curve f to the x-axis, which is f of x or delta x. Okay, then we the integral properties, and finally, to memorize this, remember this figure. Okay, very good. Now let us continue the questions. This is an example. Yeah, integral if x run from 0 to 2, then at each point in the intervals from 0 to 2, and we rotate that lines, right? It will create the cylinders here. And let x run from 0 to 2. The volume will be this guy. The same logic. We want to find the volume enclosed by the lines given on the part A, which is this figure. Let me copy it. And paste it here. Okay. Now, this area here, then it is rotate about the lines is equal, x is equal to 3, which is this line. Oh, it's not a good case. Let me rearrange it a little bit. Yeah, better. Okay, x is equal to 3 is this line here. So if it is rotate about this axis, right? And remember the volume of this guy, it will be the integral from -1, x run from -1 to 2 here, 2 pi r f x, which is the thickness, right? Let us write it with the height, sorry, the height of this. Dx here. And in this case, r is the radius from any point here, suppose it is here, any point here, right? Then the radius from this point here to the line x is equal to 3, right? And what is it? Suppose the position here is at 0.
3 minus x.
Perfect. 3 minus x 0 here is the given point is at 0. So we substituted here the distance r, the radius is 3 minus x. And the height of this cylinder is the distance from the line G to the line F here, right? And F is larger than G. So we know that it is F of x minus G of x, right? So we have everything. So let us substitute it. -1 to 2, 2 pi, 3 minus x here. F of x is x squared minus plus 4. So subtract g, where g is -x plus 2 here, dx. Okay. Now it becomes a simple integral. 2 pi is a constant, and here are the product, right? So we can take 2 pi out of the integral and make it easier. Let us simplify the second parenthesis here. Okay, this is x squared. And the second one will be plus x. And then number 4 minus 2 gives us 2 here. Okay. Are we good up to this point? Very good. Thank you. So now it becomes an easy one. Then what should we do now?
Find the antiderivative.
Let us distribute it, right? Because here it is a product. We cannot find the antiderivative of each of them because this is a product. Therefore, let us distribute it, FOIL it first, and make it easier this way. So the first guy will multiply with all of them in the second bracket. This guy here and here. Okay, it will be. I'm sorry, take you more than an hour. Here, it will be 3x squared plus 3x plus 3 times 2, and then subtract x cubed minus x squared, and the last guy is minus 2x dx. I don't have room, so I write it this way, but you see it right. And finally, it becomes an easy one. Please double check it at home and see if you find the same result. 87 pi over 2.